Okie dokie. Welcome back, Algebra 2. Let's go ahead and continue with example 2 here, which says let g of x equal the absolute value of x, which remember the absolute value of x here was the distance something was from 0. So essentially what we did if we had, 3, we'd say, okay, well, the distance from 3 to 0 is 3, so the absolute value of 3 is 3. And then on the flip side of that, let's say we had -3, so the absolute value of -3, well, distance cannot be negative, so we would just say the absolute value of -3 is 3. Okay, so remember how those work. And then we have h of x, which is going to be -8 times x, which is pretty clear. Okay, so we have two different compositions here. We have a g of h of -3, and then we have h of g of -3. Okay, so essentially what you want to do with this guy is, I like to do the compositions first. Could you plug -3 into this guy, figure out what it is, and then plug it into this guy? Sure, but you're going to need to be plugging functions into other functions anyway, so this is just will be a little bit of practice for that. Okay, so we're going to take h of, well, not -3 yet, we'll just take h of x and plug it in to g of x, which means it goes in for the x spot. So we're going to take -8x and put it in here. So we're going to do g of h of x is going to equal, we need absolute value bars, and that's from my g of x, which is on the outside. Oops, sorry, I forgot a parenthesis here. But I'm going to take -8x and plug it in. Instead of where the x should go, it's going to be now -8x. Okay? So, and then again, remember, simplify where you can. We cannot here. We can't really take the absolute value of 8. We got to keep everything, just as it is, because we can't, well, there's nothing really to simplify this with, all right? But we're not done, though, because they didn't really care about g of h of x. They cared about g of h of -3. So let's plug in -3 where x is here. So g of h of -3. And of course, if I put -3 over here, I got to put -3 over here, too, because I'm putting it in for all the x's. So we have -8 and then times -3. And then remember, we still have the absolute value bars on the outside to deal with. So let's go up here. And we have g of h of -3 equals, okay, -8 times -3 is 24. So we have the absolute value of 24, which is just 24. So we have g of h of -3 is 24. Okay, and that's it. We're done with that top part. Okay, remember, you don't do anything with this. This is just saying g of h of -3 is 24. You don't have to divide. You don't have to get rid of this -3. It's okay where it's at. It's just telling us what we put into here to get out over here. Okay. All right. Part B says find h of g of -3. So this is kind of the flip side of it. So now we're going to take g of x and plug it into where x is over here. So here we go. H of g. I'm going to keep this as x for right now. We'll worry about the -3 here. So that means g of x, which is the absolute value, goes in for just the x part right here. So we would have -8. It's just kind of hanging out. And then we have the absolute value of x now instead of just x, because we put this function in over here. Okay? Again, you can't distribute this -8 into here because absolute value bars don't quite work that way. So we can't really simplify this. So here we go. We just have to now put in -3, which is the value they wanted. So h of g of -3 equals -8. And then inside the absolute value bars, we put our -3. Okay. So now how this is different was we now have to take the absolute value of -3 first before we go any farther. Here we could wait till the end because the absolute value bars are on the outside. Here we can't. So we have h of g of -3 equals -8, and then the absolute value of -3 is just 3. So now we have -8 times a +3, so this result here is going to be -24 instead of +24. So -24 is our answer here. Okay, notice we get two different results. Sometimes that happens, and depending on what your functions are, they might even be more different than just the positive and the negative of one number. They might be like 17 and -44, which are very, very different numbers. Okay? Example 3 says let p of x equal x plus 5 and s of x equal x squared. So we're going to calculate p of s of n. So that means we're going to take s of n and put it in for function p. So p of s of n, we're going to take s, which is this guy over here, plug it in for p wherever x is. So that's right here. So we have x squared now coming from over here. plugging it in right here, but we still need this plus 5. Okay, so P of S of n is x squared plus 5. Can we simplify? X squared plus 5, can I actually add these together? No, because these are not like terms. So therefore, when we're calculating this, they did not give us, well, actually, technically, I guess we should have n, because S of n here would indicate that whatever I plug in for here should go in for right here. So let's actually erase that, and that should be an n. Okay. Okie dokie. Alright, this should be an n squared plus 5, which I'm allowed to do. N and x are kind of interchangeable. Any variable really is. So you could just change this to an n, change that to an n, and we're good to go. Okay? Now we're going to calculate S of P of n. So now we're going the other way. So we're taking P and plugging it in for S of n here. So again, we'll just change it to n's. But then we have that junk is going to have to be squared by s. So we start out with S of P of n. And we're going to change it to an n, so we have n plus 5. But then, now be careful, because we have to take all of function p, and we're squaring it. Okay, so we're squaring that whole thing n plus 5. Now, could we simplify this? You might be thinking, yeah, I could distribute this too, and it would be n squared plus 25. Careful. You can simplify it, but it's not quite that easy. Remember, squaring something means to take that thing and multiply it by itself. So that means this whole thing multiplied by itself, which means, and you might already recognize, I have to FOIL this because I have two binomials multiplying here. So this is just a more complicated example because the simplification process is a little bit more involved. Here we didn't have to even simplify at all. Here we're going to have to. Okay? So you won't always have to FOIL, but it could come about. So we do n times n, which is n squared. N plus, or n times a positive 5 is a positive 5n. Those are our outers. Here's our inners. So positive 5 times n is a positive 5n. And our lasts, positive 5 times positive 5 is a positive 25. Okay, and then we got two like terms right in here, 5n plus 5n. So we'll do n squared plus 10n plus 25. Okay, can we simplify any further? No. So then I'm just going to go back over here and say S of P of n is equal to this stuff here. So n squared plus 10n plus 25. And that's our answer. Now again, this probably doesn't seem very exciting to you because we're not actually getting answers, quote unquote, here. But we did. We got an answer. We just composed these two functions in two different ways. Notice we have two separate answers here, very different answers, depending on which way we composed. Here we put P of n into S. Here we put S of n into P. Okay, so they are different, and please remember, you always kind of start here and work your way out, all right, because that'll be key here. So whatever you have here plugs into the other equation, okay? Last example here, example 4 says let x be a real number, let r be the reciprocal function, which remember just takes any number that you put in and puts it under 1, and it says let f be given by f of x equals x squared minus 4. What is the domain? Wah, wah, wah. I know we all hate domain, but hopefully by now you're kind of getting a hang of it here. Remember, domain is just your input, or which value? Very good, x. Haha, I felt like Dora the Explorer there. Anyway, it's your input or your x value, but here we're going to focus more on the fact of it being our input value. What are we allowed to put into this function? So allowable values to put in. Okay, so just kind of remember that. That's going to be key here in a second. But first, they want the domain of r of f. So we actually have to compose these two functions. We're going to take f, we're going to plug it into r here. So we start with r, so r of f. Well, I'm sorry, let me rewrite it the way that they're doing it here with your composition. New little symbol here that we learned today. So, excuse me, r of f of x. It's not wrong to write it the other way. I just, want to use what they're using here. So that means we take f of x, which is x squared minus 4. We put it into the other function for x. So it's actually going to go downstairs here. So we're going to have 1 over x squared minus 4. So 1 over, and then we plug in x squared minus 4 here. Okay? So now if you remember, way back at the beginning of January here, we did these 2 packets, or 1 packet rather. The other one was just a worksheet. But the packet, though, we kind of broke down domain and range kind of a lot. And we did talk about functions as they're written as equations here. And there were 2 rules that we found that we couldn't do. The first rule was we could never divide by 0, because we all know that that's an indeterminate form here. So we cannot divide by 0. And the other rule was we couldn't square root any negative number without getting at least an imaginary. So for real numbers, because that's what they're asking for here, real numbers, what are we allowed to do? Well, we're not allowed to divide by 0. We're not allowed to take the square root of a negative. Everything has to be either positive or a real number down here to be able to work. Now, the only function I see that really applies to this here is this division sign here. I don't see a square root. I see a squared, but remember that's not the same thing as square rooting, so that's going to get thrown out. This doesn't apply here. We're not square rooting, so we don't care. We don't care about this guy. Okay? We do care about this guy. Very much so. Because, well, guess what? Dividing by 0 could happen here. This is the division sign. I know it looks like a fraction, but that's what fractions are. 1 divided by the junk on the bottom. So the junk on the bottom is not allowed to be 0. Okay? It will mess everything up. So what we have to do is we have to sit and think, what would make this bottom part 0? And a really easy way to do that would be, all right, x squared minus 4 is the whole bottom piece. It's not allowed to be 0. So I say x squared minus 4 cannot be 0. That's literally what this says. And that's that whole denominator piece. All right? So then I got to actually figure out what x is going to be. So let's add 4 to both sides. And I have x squared equals, or excuse me, does not equal 0 plus 4, which is just 4. And then if I wanted to just find x, I would square root both sides, and I would get x cannot equal, well, square root of 4 is plus or minus 2. Okay? So that literally, if you want to leave this like such, that is our domain. X cannot be plus or minus 2. Now if you wanted to write it in interval notation, because that's how we were used to doing it, it's actually way easier, sorry, notation here, way easier to just leave it like that. And that's fine. X cannot be plus or minus 2. That's a domain. You're telling me what I'm not allowed to put in there. You could write it in interval notation. That tells you what you are allowed to put in there. So it kind of looks at it from a different point of view here. When you're doing an interval notation, remember you start with your bare minimum, which here would be any negative number. Oops, sorry. And I'm allowed to go all the way up to, oops, negative 2. I'm not allowed to be it though, so I had to put a parenthesis instead of a bracket. And then I got more, so I'm allowed to be anywhere between negative 2 and positive 2, such as negative 1 I'm allowed to put in here. 0 I'm allowed to put in here. And then we go from positive 2 all the way to infinity. So, you know, because I could put in 144 in here if I wanted. Alright, so we got actually 3 different things. And if you look at it on a number line, we have negative 2, we have positive 2. We're not allowed to be either of those, so we put, sorry, I don't know why I keep doing that. So we put open dots on those. But we're allowed to be anything in between, and we're allowed to be anything to the left of it, and we're allowed to be anything to the right of it. So that's what these 3 intervals represent. This is all the stuff to the left of negative 2, this is all the stuff in between, and this is all the stuff to the right of negative 2. So this would be also an acceptable domain. It's just a heck of a lot harder to write than this guy. Okay, so you choose. Either way would work. I'm probably going to stick to stuff like this because guess what? It's going to be a lot less numbers, or a lot less to say what you can't put in there than it is to say what you can. Alright, but you have options here. Okie dokie. I know compositions are difficult. If there's any part of the videos you need to go back and rewatch or, you know, go through your notes and redo, please do. Tomorrow we're going to be practicing these, so I hope you're ready. Have a good night. Thanks.